Welcome to the future of financial consolidation. In this video, we'll explore how advanced machine learning is transforming Oracle FCCS from a traditional rule-based platform into an autonomous intelligence engine. By embedding Python-based regression models directly into FCCS data flows, organizations can automate complex intercompany eliminations, eliminating the need for manual matching and slow reconciliations. This shift is not just about automation, it's about enabling predictive, high-velocity financial close cycles that empower finance teams to focus on strategy, not spreadsheets. Let's dive into the technical journey that bridges legacy systems with predictive intelligence. This isn't just automating intercompany eliminations. It's about transforming Oracle FCCS into an AI-assisted intelligent reconciliation engine. By leveraging machine learning, Python services, REST APIs, data lakes, and predictive analytics, we're moving from static rules to dynamic self-learning processes. This approach targets senior Oracle FCCS architects, technical leads, and finance transformation leaders who are shaping the next generation of consolidation architectures. The goal is to create a platform that not only processes data, but also understands, predicts, and resolves financial variances autonomously. Historically, intercompany reconciliation and elimination have been resource-intensive, especially for large multinationals managing millions of transactions across various entities, currencies, and ERP platforms. While Oracle FCCS offers robust elimination capabilities, traditional implementations still rely heavily on exact matching logic, static rules, and manual investigation. As digital finance transformation accelerates, these methods are becoming unsustainable. The emergence of AI, machine learning, and predictive analytics offers a new path, one where systems can predict, classify, and reconcile transactions before they become bottlenecks. Let's consider the scale of the problem. Imagine a multinational with 350 legal entities across 45 countries, processing 18 million intercompany transactions monthly from multiple ERP sources and in 28 currencies. Traditional FCCS elimination involves partner matching, currency translation, ownership calculations, and journal generation. Mismatches are common due to timing differences, currency conversion issues, data entry inconsistencies, and ERP integration delays. The result: significant manual effort, longer close cycles, and high audit scrutiny. The real challenge is no longer consolidation, it's intelligent reconciliation. One of the most common sources of intercompany mismatches is timing differences. For example, Entity A might record revenue on the last day of the month, while Entity B records the corresponding expense at the start of the next month. This creates temporary imbalances that traditional systems struggle to reconcile automatically. These timing issues, when multiplied across hundreds of entities and millions of transactions, can add days to the close process and require extensive manual intervention to resolve. Currency conversion differences and data entry inconsistencies are other major pain points. When entities report in different currencies, small residual variances can arise due to fluctuating FX rates. Data entry errors, like missing partner codes or incorrect account classifications, further complicate reconciliation. Integration delays between ERP systems can also result in temporary out-of-balance positions, making it harder for controllers to quickly identify and resolve issues during the close. Impact of these challenges is significant. In a typical global enterprise, 20–30% of the close effort is spent investigating intercompany mismatches. This can add 3–5 days to the close cycle and requires substantial controller intervention, all under high audit scrutiny. The need for intelligent, automated reconciliation has never been greater as organizations strive to accelerate their financial close and reduce manual workloads. Focus is shifting from basic consolidation to intelligent reconciliation. By integrating machine learning with Oracle FCCS, organizations can move beyond reactive processes and start predicting, classifying, and automatically eliminating transactions. This proactive approach not only reduces manual effort, but also improves the accuracy and speed of the financial close, setting the stage for a truly autonomous finance function. Let's compare legacy and intelligent architectures. Traditionally, data flows from ERP to FCCS, where match rules and manual investigation drive eliminations, a reactive process. In the intelligent architecture, data first lands in a data lake, then passes through a machine learning engine for predictive matching before reaching FCCS for automated elimination. This predictive process transforms FCCS into a decision support platform, enabling faster, more accurate closes. The core philosophy behind this transformation is a shift in mindset. Instead of asking, "Why does this variance exist?" the system now asks, based on historical behavior, "What is the most probable resolution?" This enables FCCS to evolve from a consolidation engine into an intelligent decision support platform, where machine learning continuously learns from past data to resolve variances proactively. High-level technical architecture underpins this transformation. Data flows from SAP, Oracle ERP, and NetSuite into Oracle Data Integration, then into an OCI data lake. Here, a Python-based machine learning engine performs prediction and classification. Results are sent to FCCS via REST APIs, which automate journal creation and posting, feeding into the consolidation process. This seamless integration enables end-to-end automation and intelligence. Architecture begins with the source systems layer, supporting Oracle ERP Cloud, SAP S/4HANA, eBusiness Suite, NetSuite, and JD Edwards. This diversity ensures that organizations can consolidate data from multiple ERP platforms, providing a unified foundation for downstream automation and intelligence. Next is the integration layer, powered by Oracle Data Integration, FDMEE, EPM Integration Agent, and Oracle Integration Cloud. This layer handles data extraction, validation, and enrichment, ensuring that only high-quality relevant data enters the data lake for machine learning processing. Data lake, typically built on OCI object storage, serves as the central repository for historical transactions, prior eliminations, variance patterns, and ownership history. This rich dataset is essential for training machine learning models, enabling them to detect patterns and predict future variances with high accuracy. Machine learning processing layer leverages Python, scikit-learn, XGBoost, TensorFlow, Pandas, and NumPy. Here, the system performs pattern detection, anomaly identification, transaction clustering, and variance prediction. This is where the intelligence is built, enabling the system to learn from historical data and continuously improve its predictions. FCCS integration layer uses REST APIs to extract data, create and post journals, and automate processes. This allows for seamless orchestration between the machine learning engine and FCCS, ensuring that predictions and reconciliations are executed efficiently and accurately. Bridging Python intelligence with FCCS is made possible through Oracle EPM Cloud's REST API framework. The process begins by extracting transactions, running them through Python-based machine learning models, generating journal entries, and triggering the consolidation process, all in an automated, auditable workflow. Oracle EPM Cloud's REST APIs enable external orchestration of FCCS processes. Transactions are extracted, analyzed by machine learning models, and used to generate elimination, adjustment, and reclassification journals. The consolidation process is then triggered automatically, ensuring a streamlined and efficient close. Regression models are at the heart of predictive eliminations. By analyzing historical elimination data, these models learn expected variance patterns and can predict future mismatches. This enables the system to proactively resolve variances, reducing manual investigation and accelerating the close process. Effective machine learning depends on robust feature engineering. Input variables include entity pairs, currencies, account types, historical variance patterns, and transaction timing. By capturing these dimensions, models can accurately predict and classify variances, supporting more intelligent eliminations. Variety of regression algorithms are used, including linear regression for simple relationships, random forest regression for complex, nonlinear patterns, and XGBoost for enterprise-grade accuracy and speed. XGBoost is particularly valued for its high accuracy, explainability, and fast processing, making it ideal for large-scale financial close environments. Additional FCCS logic relies on exact matching. If invoice and counterparty amounts are identical, it's a match, otherwise it's an exception. Machine learning introduces fuzzy matching, where small differences are evaluated in context. For example, a $300 variance due to FX rates or timing can be auto-reconciled if the model's confidence is high. This dramatically reduces exceptions and manual reviews. Technologies like Levenshtein distance for partner matching, cosine similarity for transaction descriptions, and clustering algorithms for transaction grouping enable sophisticated, context-aware matching. These tools help the system identify likely matches, even when data isn't perfectly aligned, further reducing manual intervention. Autonomous elimination workflow is fully automated. Load transactions, run machine learning classification, predict matching pairs, generate eliminations, submit FCCS journals, launch consolidation, and publish dashboards. This end-to-end automation eliminates human intervention, freeing up finance teams for higher-value activities. Not every transaction should be automated. Machine learning models assign confidence scores to each match. Transactions with scores above 95% are auto-eliminated, those between 85–95% are sent to a review queue, and those below 85% require manual investigation. This ensures robust governance and auditability, balancing automation with control. Controller dashboard provides real-time metrics on match rates, variance prediction accuracy, journal automation percentages, and days to close. Visualization platforms like Oracle Analytics Cloud, Power BI, Tableau, and OCI data science dashboards offer deep insights, enabling continuous improvement and transparency. Security and governance are critical. Segregation of duties ensures that machine learning models cannot approve journals, controllers retain final authority. Every prediction is logged with input features, confidence scores, and rationale, creating a robust audit trail. Model governance includes version control and approval workflows before deployment. Comprehensive audit trail is maintained for every prediction, including all input features, confidence scores, and the rationale behind each decision. Model governance is enforced through version control and mandatory approval workflows, ensuring that only validated models are deployed into production. Organizations implementing machine learning-driven eliminations see dramatic improvements. Close cycle times reduced by 40–60%, manual reconciliation effort cut by 70–90%, improved data quality by up to 80%, faster audit responses, and controller productivity doubled or tripled. These outcomes demonstrate the tangible value of autonomous financial close. Future extends beyond intercompany eliminations. The same architecture can automate minority interest calculations, tax provision allocations, equity pickups, cash flow classification, ownership change analysis, predictive consolidation, and even AI-generated close narratives. This paves the way for a fully autonomous financial close. By 2030, leading finance organizations will operate autonomous close platforms where machine learning continuously predicts, reconciles, eliminates, consolidates, and explains financial results with minimal human intervention. Oracle FCCS will remain the consolidation engine, but artificial intelligence will drive the intelligence layer, transforming finance forever. Future FCCS architect will need expertise not only in consolidation rules and close processes, but also in data science, Python engineering, OCI data platforms, REST APIs, ML ops, and AI governance. The evolution from FCCS consultant to autonomous finance architect is already underway, and those who adapt will lead the next wave of finance transformation. Bridging the gap from legacy consolidation to predictive intelligence requires a technical and cultural shift. Organizations must invest in data infrastructure, machine learning capabilities, and change management to realize the full benefits of autonomous financial close. The journey is challenging, but essential for future-ready finance teams. Machine learning models continuously improve as they process more data. Each close cycle provides new insights, allowing the system to refine its predictions and automate more exceptions over time. This creates a virtuous cycle of increasing automation and accuracy. Predictive analytics not only accelerates the close, but also enhances data quality and auditability. By identifying patterns and anomalies early, finance teams can address issues proactively, reducing risk and improving compliance across the organization. AI-generated close narratives are on the horizon. These tools will automatically explain financial results, variances, and trends, providing controllers and executives with actionable insights in real time. This marks a new era of transparency and strategic decision-making. As automation increases, governance becomes even more critical. Organizations must establish clear policies for model approval, monitoring, and retraining. Regular audits and transparent reporting ensure that automation enhances, rather than undermines, financial integrity. With routine tasks automated, controllers can focus on higher-value activities like analysis, strategy, and business partnering. Their role evolves from transaction processing to oversight and insight, supported by real-time dashboards and predictive analytics. Transitioning to autonomous financial close requires effective change management. Training, communication, and stakeholder engagement are essential to ensure adoption and maximize the benefits of new technologies. Success depends on both technical and human factors. Cloud-native data engineering is a key enabler of autonomous close. Platforms like OCI provide the scalability, security, and integration capabilities needed to support advanced machine learning and real-time automation across global finance operations. Architecture is designed for scalability and flexibility, supporting growth and adaptation as business needs evolve. Modular components and open APIs allow organizations to expand automation to new processes and integrate with emerging technologies. Continuous improvement is built into the system. Regular feedback loops, model retraining, and performance monitoring ensure that automation remains effective and aligned with business goals. This adaptability is essential for long-term success. Engaging stakeholders from finance, IT, and audit is crucial for successful deployment. Cross-functional collaboration ensures that automation meets the needs of all users and delivers maximum value across the organization. In summary, automating intercompany eliminations in Oracle FCCS with advanced machine learning is a game-changer for finance. It reduces manual effort, accelerates the close, improves data quality, and positions organizations for the future of autonomous finance. The journey requires investment in technology, skills, and change management, but the rewards are transformative. As we look to the future, the evolution from FCCS consultant to autonomous finance architect is well underway. Those who embrace machine learning, data science, and automation will lead the next era of finance transformation. The autonomous close is not just a vision, it's becoming reality. Thanks for watching.